Okay, so today we learn Signum function. Signum function. So what is the Signum function and how do we represent it? So the Signum function is f of x, you represent like this, f of x equal to Signum function, we represent like this. Signum of x, like this we represent. Signum of x, like this we represent, and this equal to we write as, just a minute. So signum of x, we represent like this. Signum function represent like signum of x, and this is equal to what? This is simply minus 1 if x is less than 1, if x is less than 0, and this is 1 if x is greater than 0, and 0 if x is equal to 0. So signum function means this. So here these are called piecewise defined function. This is also called piecewise defined functions. Okay, anyway, that I will discuss later. So now f of x equal to signum of x, that is defined like this, and this can be also, this also can be represent another way also. We can say, what is that? Signum of x equal to, here see, x by step x, x by mod x. Okay, x by mod x, this is x by mod x, or mod x by x if x is not equal to 0, and this is 0 if x is equal to 0. Okay, that means when x is not equal to 0, then you take either this or signum value. You have to take signum x, you have to take as either this or this. Okay, if x is not equal to 0, if x equal to 0, then what you should do? If x equal to 0, if x equal to 0, it is 0 only. If x is not equal to 0, that means what? You can take either this or this, both are same. Okay, what does it mean? I'll explain. Okay, now what I told, signum function means f of x equal to, we write like this, or signum of x, SGN, signum of x is minus 1 if x is negative, and plus 1 if x is positive, and 0 if x is 0. That's it. That's what is the definition. So now, okay, so for example, first let me write this one, f of x equal to, I told, or signum of x. Signum of x is what? Either you take like this, mod x by x you take, okay, if x is not equal to 0, and 0 if x is 0. When x is 0, you cannot take this definition. This definition is only when x is not equal to 0. When x is not equal to 0, this definition. Okay, when x is 0, when x is 0, this definition. So what does it mean? When x is not equal to 0, this one, what will happen to this one? When x is not equal to 0, that means x is either greater than 0 or x is less than 0. X is not equal to 0 means what? Either positive or negative. Okay, x is 0 is here. So x is not equal to 0 means x greater than 0. X greater than 0 means what will happen? X greater than 0 means mod x becomes x by x, which is 1. Okay, and if x is less than 0, mod x becomes what? Yesterday only we discussed now. When x is less than 0, mod x becomes minus x minus x by x, minus x by x, which is 1, minus x by x. When x is less than 0, then this one I am writing. That means what I wrote is mod x by x becomes what? This becomes what I wrote. This mod x by x becomes x by x when, if x is greater than 0. Okay, now let's take when mod x by x becomes what? When x is greater than 0, mod x becomes x by x. That is what is 1. That's what I wrote here. When x is less than 0, when x is less than 0, if x is less than 0, mod x becomes minus x by x, which is what? Minus 1. So this is what is minus 1. So that's what I told. That means whatever I wrote, definition back also same. When x is less than 0, mod x by x becomes minus 1. When x is greater than 0, mod x by x becomes plus 1. When x is 0, you should not take this definition. This definition is when x is not equal to 0 only, you should take this. Either this also, mod x by x or x by mod x, same. So therefore, you should not get confused. So that means signum function can be defined both the ways. What is the signum function can be defined both the ways? What are the both the ways? You may simply say minus 1 if x is less than 0, if plus 1 if x is greater than 0, 0 if x is equal to 0. You may say like this, or signum function of signum of x, you may say like this. What you may say? You may say mod x by x if x is not equal to 0, and 0 if x is equal to 0. This and this both are same, because not equal to 0 means I told, if it is greater than 0, then this is 1. If it is less than 0, it is minus x by x, which is minus 1. That is only here, this only you get. Again, this is nothing but this only you get. Or you can also say like this also, this signum of x can also be defined as what? X by mod x also. Like this also, sometimes it can be defined like this also. If x is not equal to 0, and 0 if x equal to 0. Like this also you can define. So, but all of these are same. Okay, finally understood. Now graph of signum function. Graph, what is this graph will be like? When 0, when this is x-axis and this is y-axis, when x is 0, it is 0. When x is 1, when x is 0.1, it is 1. When x is 0, it is here. When x is 1, this is 1. When x is 2, this is 1. When x is 3, this is 1. When x is 4, this is 1 only. Because this is y equal to 1. The f of x, signum of x is, f of x means y only. So that is 1. So when x is, when x, whatever you take, positive values, when x you take positive values, you get f of x value 1 you get. When if you take x is minus 1, if x is minus 1, this is minus 1. When x is minus 1, and then when x is minus 0.1, this is negative only. When x is less than 0, it is negative. Like this, minus 1 also, minus 2 also. This all, for all negativity, it is minus 1 only. So the graph you get is like this. Graph is like this. So, but here it is not here. When x is 0, it is here. So graph is simply like this. That means graph will be like this. 0, it is 0. And for 1, 2, 3, all this side. For 0, minus 1, minus 2, all this side. So this is a graph of signum x. So then signum x is this. So then, so some of the examples I will give you. So what does it mean to write signum of, for example, I wrote here, signum of minus 2 is what? Is minus 1. Signum of, for example, I am writing 100, I am writing signum of 100 how much? Signum function of 100 is how much? 1. Like that it is, because it is x is, now here signum of x is positive, so 1, x is negative. So signum of 22.9 is 1, because it is positive. Like that you have to check. So now I'll write like this also. Signum of x square plus 1. This is 1. Simply it is 1. Why it is 1? Signum of x square plus 1 is 1. Why? X square is positive, plus 1 is, this is positive. X square plus 1 is positive. Therefore, its value is 1. And for example, if I write signum of minus x square minus 1. This is x square positive. Into minus is negative, minus 1 negative. Therefore, it is minus 1. So like this, you can write like this also. So that is a signum function. So here I explained this one. This one I explained. What is this? This one I explained. What is that? Signum of x square minus 1. When x square minus 1 is less than 0. That means when x lies between minus 1 and 1. That is signum of x square minus 1 is minus 1. When x is plus or minus 1, this becomes 0. Signum of 0 is 0. When x does not lie between these, then this is positive, that is 1. So that's what is signum function we discussed. Okay. So then let's go to next function. So what are those? Exponential function. Exponential function. So what is this exponential function? Already we discussed this is f of x, f maps R to R defined as f of x equal to a power x. What is a here? A is not equal to, a is greater than 0 and a not equal to 1 we say. If it is 1, no use. If it is negative power something, we can't define it properly. So therefore we take a is greater than 0, this is a condition, and a not equal to 1. Okay, a is a positive real number. A greater than 0 means a is a positive real number but not 1. Is called exponential function. Is called exponential function. So already we discussed exponential function. Where we discussed exponential function? Logarithms, exponent. Logarithms we discussed. In logarithms we discussed exponential function. So what are the examples? Example for this is 2 power x and 1 by 2 power x, or 1 by 3 whole power x, and 5 power x, and 100 power x, and whatever. So these are all 0.9 power x, like this. These are all exponential functions. Power variable is there. So these are exponential functions. So now, okay, we'll see it's graph important here. Exponential function graph important. Okay, number one point is f of x equal to a power x. I told here. Number one point is x is any real number. That means x value here. X value in f of x. X value is domain. That means domain is all real numbers. And then next, what is range? Range means f of x value. Range means f of x value. What is range? Range means a power x. So a is already I told. What is a here? A is greater than 0. A is positive. When a is positive, a power x, that implies a power x also greater than 0. When a is positive, a power x also positive. For example here, f of x equal to, let's take, so that means what? A power x means f of x. F of x is always positive. Therefore range is what? Range is r plus. That only what we say is 0 to infinity. Okay, we'll see this now. F of x equal to 2 power x, for example, 2 power x. So here 2 power x means whatever x you take also it is positive. So let's take here this x-axis and this is y-axis. Let's take this y-axis, 0. So now if you put 0, put x equal to 0, then what you are going to get? For 0, you are going to get 1. When x is 0, f of 0 is what? So 1. So that's why I plotted the 0, 1 I plotted, 0, 1 I plotted. So then f1, if x is 1, f of 1 is 2, f of 2 is what? 2 square. So like this. So for Signum function, what is the domain and range? Domain is all real numbers. That's true. Domain is all real numbers. That's true. Range is what? What is range? Output. Output is -1, 0, 1. Yes, that's good. Very good. Okay, somebody is saying this. Yes, that's good. That's true. But whereas here, this is the domain and range is this. So what is domain? All real numbers. Range is this. Okay, anyway, f of -1. F of -1 is what? 2 power -1, which is 1 by 2. F of -2 is what? 2 power -2, which is 1 by 2 square, which is 1 by 4. So like this, f of -3, you're going to get 1 by 8 and so on. So here, this one plotted and this one. So 2, this is, if it is 1, it is 2. If it is 2, it is 4, like this. It's going like this. It's increasing like this. But if it is -1, it is 1 by 2, like this. If it is -2, -1, -2, it is like this. In -4, it's even closer. It's going close to 0. But it can never be 0. 2 power x can never be 0. Whatever you take, it's going to be very, very, very small, very close. Yes, x tends to minus infinity. Yes, x is coming close to minus infinity. 2 power minus a, 2 power x. 2 power x tends to 0. It comes close to 0. That's the reason it is like this. But it can never be. But 2 power x is cannot be negative. Never be negative, or 2 power x can never be equal to 0. That means 2 power x, that's the reason I wrote 2 power x is, you can see, always greater than 0. The graph is like this. So it is increasing like this. So it increases. Okay, this is 2 power x, and if you want you can take 3 power x, same thing, you will get same thing, same graph. And e power x, most importantly, exponential functions. One exponential function is e power x. So what is e power x? What is e power x? E power x is like this: 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus x power 4 by 4 factorial, so on up to infinity. So this is what is called exponential function. Example, that is e power x. Okay, that's e power x. Just okay, here is one doubt. What is this factorial? Just I will give you a brief. So product of n natural numbers is called n factorial. So that means 5 factorial is product of 5 natural numbers. Okay, 4, 5. This is 5 factorial. So 2 factorial means what? 1 into 2. 3 factorial means what? 1 into 2 into 3. This much you understand. So now here e power x is this one. So then you should not, why I am telling is e power x will come. So you should not get confused. What is e power x? E power x is this. So this is e power x. Now in the place of x, if I put 1, e power 1, what is e power 1? 1 plus in the place of x1, 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial and plus so on. So e power 1 is e. That is 1 plus 0 0.5. 0.5 plus this is 0. This is 1 by 6. 1 by 6 means what? 0.1. The next 4 will be there. 1, 6, 6, 6 like this. So 0.1666 plus 1 by next 1 by 4 factorial is 1 by 24. That is 0.04. And then next you will get 96 means 4 will be left. 4 if you put no, 1 will come. That is 0.041. This much is enough, and so on up to infinity it will go. It is irrational number. Just I was trying to explain e. What is e? So here 1 plus 1, that is 2. Okay, 2.5 will keep 2.5. Till here it is clear, 2.5. Now we'll add this one. If I add now, this becomes what? This is 041. So this is 6, 7. This is what is 10. This is what is 10. Understand, this is what is 10. So this is 6, 7. This is 0 and this is 2 and this is 0 again. So then what I get is 0, 2, 0, 7, 6 like this I am getting. So that means this is 2.7. Okay, as of now here 0 only there. 0, 7, 6, something like this I am getting. 712 you get actually. If you round up, no, 712 something you get. So that means E value is approximately 2.7. 2.7. Approximately 2.7. This is approximately 2.7. This is what is E. So if you want, you can take this one. What is E? This is an irrational number because no, this never ending. So E is an irrational number. Irrational number. Why it's an irrational number? It's since it is non-terminating non-repeating decimal. Non-terminating non-repeating decimal. So this is non-terminating non-repeating decimal. Therefore this E is approximately 2.7. It's not exact value, so it is an irrational number. So e power x is and then e power x is what is this? E power x? Exponential function. What is its graph? This graph is same because it's a 2 point something. Whatever 2 or 3, you got, the graph you get is same like this. So only you get the graph will be like this. Okay, this is about e power x. I think you understand this is exponential function. The exponential function domain is this and range is positive because only from year to year you are getting. From 0 to infinity only you are getting. Y values you get only this. The curve is above x-axis. The curve is above x-axis means y value is only positive. So therefore, this you can say that exponential function always positive. Okay, all right. Okay, then next logarithmic function. Logarithmic function. What is this logarithmic function? Let's see. So f maps r plus 2r defined as f of x equal to log x. Okay, log x, what does it mean, log x? Log x here, let's say base a, I'm writing, nothing is there, means let's say base. Log x base a, but here a is what you know, because where from this has come. So log y equal to, let's say x, then y becomes what? Y becomes log x to the base a. Already I told you in logarithms foundation, I told already. In bridge course I told you, a power y equal to x. If you want, you can go back and see. If you type my name Subhash Paila, then you will get logarithms. One video is there, logarithms and logarithmic inequalities. Two videos are there. You can go through that logarithmic functions. You can go through properties and all. Here I am telling briefly, a power y equal to x, then y equal to log x base a. But already we know what is a. We know a is greater than 0. A is not equal to 1. We know. And what is x? A power y value. A power y is what is x. A power y value is x. X is a power y. A power y is always positive. Therefore, x is always positive. That's what I wrote here. Log x to the base a. Log x to the base a. F of x is log x to the base a. So then x is always positive, because logarithm cannot be defined for negative values. You see, by the definition of logarithm itself says x is always positive. So to the base a. And I explained very clearly what are these properties. But here I am going to give some examples for logarithmic function. So log x to the base 2, okay, log x to the base 3, or log x to the base 1 by 2, something like this, logarithmic functions. Okay, these logarithmic functions, what is the domain? Domain is, what is the domain? Okay, domain of logarithmic function is, we know, r plus, that is 0 to infinity. It is not defined for 0 also. 0 to infinity, more than 0 it should be. 0 is excluded. What is range? Range is all real numbers you get. All real numbers you get. Okay, then the graph. Now let's take log x to the base 2 graph. Log x to the base 2 graph is exactly opposite to e power x. So now log x. So now first log 0 is not defined actually, but log 1 is what? Log 1, already I told log 1 is 0. Log 1 is 0. Why? I already explained this. A power 1 is a power 0 is 1. So 0 equal to log 1 to the base a. I told you this one. Okay, if you 0, now if you take log on both sides, this goes this side, log 1 to the base a. Log 1 to any base a is 0. So log 1 is 0 here. A is 0. A is 0. Already I taught that one. So, okay, log 1. So now here, here log 1 to the base a. And log 1 by 2. If I take 1 by 2, what will happen? If I take 1 by 2, it is minus 1. If I take 1 by 2, it is minus 1. You take log 1 by 2 to the base 2 is what? Log of 2 power minus 1 to the base 2, which is minus 1. So minus 1. Log, not speaking. Log 1 by 4 to the base 2. 1 by 4, again half of it. So minus 2. It is minus 2. Minus 2. So then this curve will be like this. And then for 2, what will happen? For 2, it is 1. Log 2 is 1. Log 4 is what? Log 4 is